linear inequalities. Let me turn one of those on, that light is way too bright for my eyes. Thank you. If I give you that linear inequality, could you graph that?
Yeah.
We should be able to. If we have any kind of linear equation, we typically like to graph it in slope-intercept form, am I right? What would be the slope of this linear inequality? 1 over 2 and the y-intercept? 3. So when we graph this, we're going to put a dot at 3 on our y-axis. The slope is 1/2. What does that mean?
You go up 1, rise 1 over 2.
Good. Up 1 and over 2. Now instead of going up 1 and over 2, what else could I have done?
Down 1 and left 2.
Down 1 and left 2. As a reminder, you need to have a minimum of 3 points on your graph, and all of your points need to fall in a straight line. If something happens that they don't fall in a straight line, is the graph just weird, or did you make a mistake? You probably made a mistake. The graph, if you're graphing a linear function, it's going to be in a line if you did it correctly. If you did something wrong, it's going to look weird, and you need to go back and try to assess where you made your mistake. Our next step in graphing is to draw our line in. Will we use a dashed or a solid line? A dashed. Remember, if it's less than or greater than, we are going to use a dashed line. If it's less than or equal to or greater than or equal to, we're going to use a solid line. In our case, what are we going to use? A dashed line. Is that it? Are we finished graphing? It is an inequality, so what else do we have to include with our inequality? What do we do with 0?
Replace the fraction line.
Substitute it in to see if it is true or false. Good. So let's test the ordered pair 0, 0, which happens to fall right here. So let's substitute 0 in for x and y. Half of 0 is still 0, plus 3. Is 0 less than 3? That's true. So what does that mean about the whole side with 0, 0? That's the true side. Any ordered pair that we would pick, it doesn't matter what ordered pair, if we were to pick any point along on this side of our graph, it is going to be true for the inequality. It's going to be a solution for that inequality. Remember, solutions are ordered pairs that make your equation, or in our case, inequality, true. So our solutions are everything on this side. What does that indicate about the other side of our line?
False.
These are the false sides. So if we tested an ordered pair, would it be a solution? Would it be true for this inequality? It wouldn't. Those ordered pairs on the left side, or the upper half of our graph, are not solutions. Any questions here? If it's not in, let's make this an inequality line equation. If it's not in slope-intercept form, like in this next example, is that going to matter? No, we should still be able to graph it. We need to put it into slope-intercept form. So what would be your first step? Subtracting 3x. Now, we're left with negative 2y is less than or equal to negative 3x plus 6. And our next step, what would we do? Divide by a negative 2. On the assignment the other day, I saw a lot of you were forgetting to bring down that negative with the 2. It must stay with the 2. Another mistake I saw often was you divided by your negative. What does that do to the inequality symbol? It flips it. That rule with inequality symbols always holds when you're talking about inequalities. As far as dividing or multiplying by a negative, you're going to flip your inequality symbol. That will always hold true for any inequality. Here we have negative 3 divided by negative 2, which is positive. 3 has x, plus 6 divided by negative 2 is negative 3. Let's go ahead and graph. What is our slope?
3. 3/2.
3 over 2, very good. And the y-intercept?
-3.
-3. So put a dot at -3 on your y-axis. The slope is 3 over 2, so that means we will rise 3, run 2. We could continue on, rising 3, running 2. This time will we use a dash or a solid line? Will be a solid line again. Are we finished? Now we have to shade. So test your ordered pair. Let's test 0, 0. Substitute for x and y. So we have 0 is greater than or equal to 3/2 times 0 plus a -3. 3/2 times 0 is 0 plus a -3. Is that true? Is 0 greater than or equal to -3? That's true. So we are going to shade the top half. The side with 0, 0 was our true side. The other side is the false side. Yes, you could have. What about this next one? What if I give you this equation? X equals 2. And I meant to say equals, not use an equality here. X equals 2. Could you graph that on an x, y axis? We should be able to. Taylor, you with us?
Yeah.
Go to 2. Is it going to be on your x or your y axis? How do we know? Do you remember the trick I told you to remember? What letter? The letter V is in the letter X, right? V for vertical. Do you remember me telling you that? V for vertical. So you're going to have a vertical graph at 2. It'll look like this. What if I change this to make it x is greater than 2? Could you graph that? Instead of our solid line, what would we have? A dash. So just right next to it, I'm going to make it a dash line to indicate that it should have been a dash. Now we have to shade. When we test our ordered pair 0, 0, we're going to put 0 in for x and y. But we don't have a y to substitute in for, do we? Is that a big deal? No. All we can do is substitute in for x. 0 is greater than 2. Is that true or false? That's false. So that means the side with 0, 0 is the false side. We want to shade the true side. We would shade the right hand. And this should make sense because values that are greater than 2, aren't they going to be to the right of 2 on your number line? 3, 4, 5, 6. Those all have x values that are greater than 2. We're going to spend some more time practicing graphing inequalities today before we take our quiz on Monday. Like I said, we'll review briefly before our quiz on Monday, we'll review after for our test that's coming up on Wednesday, and then Tuesday will be devoted strictly to reviewing, getting ready for your test.